Hello, welcome to Grandpa Hunter's YouTube presentations on our solar system. A few points of housekeeping. I'm doing this for our 6 grandchildren and children of all ages, but I want my fellow lawyers to see what they and we can do with low-cost, easy-to-use software. It should have many purposes for presentations to court, to the public, to our clients, and for marketing. And so I hope you'll find something of interest in this presentation. This first slide just shows you a clip from our solar system, but there's much more than this. Now you'll see the sun is here, and the farthest planet is way out here, all scrunched up. But I can take Pop and I can drop him into the sun or putting up on one of the outer rings or over to the left or back again. So that's how we're going to manage this. Feel free to read this narrative on your own. But kids, have you ever really tried to figure out who you are and where you came from? The solar system is part of something unbelievably and almost unimaginably bigger than that. It's part of the universe. The universe began with a big bang. I'll talk about that a little bit later, which occurred perhaps 13.8 billion years ago, and our universe is expected to last another 16 billion years or so. Our sun formed from swirling gases pulled together 4.6 billion years ago, just about a third of that. And so did our planets as they swirled around that hot mass that became our sun. Not going to panic. Hardened and got hit by objects in space. I found this NASA presentation, or maybe it's from the Smithsonian, showing a graphic description of how our universe formed and how the galaxies within that universe formed. So down here, for some reason, something that was a few microns wide. It's hard not to look over there. That's where my screen is. A few microns wide exploded into a big bang. And then there was a period of darkness, and then the gases became illuminated. And around 400 million years ago, stars began to form. And you can see there were great quantum fluxes, and galaxies, planets, and satellites around the planets formed. The acceleration, as you can see, as this thing's getting wider out here, is now projected, and as the studies say, that it's accelerating and expanding. It's not slowing down like a rubber ball, like a ball connected to a rubber band throwing out and coming back, which is the way I always perceive this. And to add to that, there are things called dark matter and dark energy that makes up well over 90% of our universe, and we haven't even been able to detect it except through the theories, quantum theory and other remarkable theories. A big question in science until the 1920s is, are we the only galaxy, and is that outer space, just our galaxy? As I look up, I see I have my poster of the Milky Way right in front of me to keep me reminded how small we are and how vast and mysterious the universe is. We are one, it turns out, of billions of galaxies and trillions of stars and planets. In the midst of all that, we now learn that our universe is still expanding. And as I mentioned, there's this stuff called dark matter and dark energy. That's enough to give you a headache. The good news is Pop's only going to show you our solar system. Now remember, read this at your leisure. You're going to have access to a PDF of this. My own grandchildren are getting their very own posters and charts of this. So here's a picture of our solar system. Don't ever expect to see a photograph like that. In fact, I'll show you in a minute something that might be a little bit like a photograph. But real quickly, there's the sun. There is our closest planet, Mercury. So close it looks like it's ready to touch the sun. Venus covered with clouds, poisonous. Our Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. And asteroids and comets. So let's go forward and see what we've got. Here is our Earth. And I even attempted to aim it towards North America where we live. So even on this chart, you can see how incredibly tiny we are compared even to our solar system, not to mention our universe. Icy worlds, comets, and asteroids. And I'll draw your attention to asteroid belt here between Mars and Jupiter, and some other things you'll learn. Here are, let me move me out of the way, many thousands of small worlds covered by ice and dust orbit beyond the planets. These remnants of the solar system formation are so distant from the sun, they receive almost no warmth from the sun. Many of them orbit in a disc-shaped zone beyond Neptune called the Kuiper Belt. The largest of the icy worlds, including Pluto and Eris, are also called dwarf planets. And those my age and even a little bit younger can remember when Pluto was supposed to be a small, distant, discovered planet, but now it's no longer, it's been demoted. Most asteroids are in the main asteroid belt between the orbits of Mars and Jupiter. Some asteroids have orbits that come close to actually crossing the Earth's orbit. And I don't want to scare you, but asteroids have struck the Earth in the past many, many, many times, but a couple times so massive that they were able to cause extinctions of major creatures at that point. So comets and asteroids. Note, comets come from outside of our solar system, and they'll come through, and sometimes you actually can see these guys coming around, and then they eventually slingshot around the sun and go back out that way. This is a little more like what I think the solar system might look like from a distance, but it's not. This is a star cluster. So the planets are still too small. You can't even see them. But for example, if this was the sun right here, this might be Jupiter, this might be Saturn, this might be Uranus, and way tiny one right there, that might be your Earth right there. Again, it's a star cluster, which means it's way far away. It probably is in this galaxy. And then through the galaxy, you can see stars. But I think this one right up here looks like it's actually a galaxy. I'll bet you this was taken by the Hubble telescope. And the astronomer Hubble is the guy that discovered that we aren't the only galaxy. So, and we're a little out of order, but I will show you. Here is our sun. The sun is 4.6 billion years old. The circumference of the sun is 4 million kilometers, and it is It makes up about 90% of the mass of the solar system. Here is scale. Again, you'll never see a photograph like this. But if you look at the little one, Mercury, here it goes. It's the smallest and it's the nearest to the sun. Venus, you can follow these lines. It's next to Earth and it's almost as big as the Earth. Here is our Earth. And there it is down there, blue. And then Uranus is one of the two smaller gas giants. It's out right before you get to Neptune, and there it is. There is there it is. There is Neptune, the farthest out now that Pluto's been demoted. And this, let's see. This yellow one is not the sun. It is our biggest planet. It's Jupiter. Then we've got Saturn, which is next right here. So these are not to scale, but they give you an idea that some of our planets are very large compared to some of our other planets. Mercury, I never heard it called the swift planet. I will mention that these planets are named for a Greek mythology, and Mercury was a messenger, and he did have wings on his ankles, and it's all made up. It's all myth. But its length of year is only 88 Earth days, but it takes 58 days to go around instead of 1 day like ours. Venus, I have heard it called the cloud planet. It's got poisonous clouds. We have sent satellites in that have gotten crushed by the pressure, but it's almost as big as our Earth. Its year is 225 Earth days, but it takes a year to spin around once, its rotation period. Our Earth, home sweet home, 365 days a year, 23.93 hours, in other words, 24-hour days. And here we are. There's the North America, and there's the eastern side of North America where West Virginia and North Carolina reside. Mars, also called the red planet because of the oxidated, the red iron in its soil. And it is only about half as big as the Earth. I think it's actually less than half of its mass. Its rotation period is almost the same as ours, but its year's twice as long as ours. Jupiter is huge, and at one point we were able to see an asteroid slam into Jupiter, and I've actually seen those recordings myself. Its year is almost 12 Earth years, but it spins around in only 10 hours, believe it or not. Saturn is the ringed planet, and you can see that it takes 29.5 Earth years, but it spins around in only 11 hours. Uranus takes 84 Earth years to go around the sun, but it spins around in just 3/4 as long as our days at 17 hours. Neptune is the farthest out, and its year is 165 Earth years. The sky is the limit, and before I see that, I want to go back and find something. Yes, I wanted to show you this. This is taken with the Hubble telescope, and it took until about 1920 to find out if we were the only universe. And it took really powerful telescopes to show us this. But look what we've got here. You see how this is like a point with little rays sticking out? That's probably a sun. That's probably a star. But look at this thing here. They were able to see and hear that there are billions and billions of galaxies. And it took the Hubble telescope to show us that. So I'm sorry I skipped over that. I'm going to go through real quick now. It doesn't take very long. There's the narration. There is the example of the Big Bang and getting to where we are now. There's the Hubble telescope. There's our solar system, our Earth, our icy worlds, descriptions of the icy worlds and the asteroid belt, what I think our solar system may look like from a far, far distance, our sun, the relative sizes, Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. The sky is the limit. And what's the big dream? And that's what I thought of. I'm not saying that these kids, I'm sorry, kids, I'll get out of your way. I'm not saying that these kids are going into outer space. I don't mean that. Maybe they will, maybe they won't. They're living at a time of the most rapid change in history. We only learned that there are other galaxies 100 years ago. Now they're going to have to grow up and adapt to a world that's getting much too warm, much too fast. They're going to have to get educations. They're going to have to make their way in the world. They may or may not have tragedies. Most of us do. But right now, the big dream is the big question mark. And Pop-Pop's heart strongly is hoping that his grandchildren and his children do well.